Hello, very good morning, students. Welcome to Byjus exam prep. Good morning, all of you. How are you all? Very good morning. So today we're gonna discuss about the degree of freedom concept. Like in the last segment, we have studied the concept of think what is a kinematic pair. तो आज हम लोग degrees of freedom के ऊपर थोड़ा discussion करेंगे. तो before starting the session, please let me know whether my audio and video all good, all perfect. Yes, everyone. Take from my end also. Okay, all good. परफेक्ट है चलिए तो आज की शुरुआत विल बी हैविंग अ वेरी इंटरेस्टिंग टॉपिक दैट इज द डिग्रीज ऑफ फ्रीडम और यहाँ से क्वेश्चंस आपके बहुत सारे एग्जाम्स में दे आर यूजुअली आस्किंग तो इट्स वेरी इंपॉर्टेंट कि आप इस पर थोड़ा सा ध्यान देंगे और ज़्यादातर दे आर आस्किंग यू 1 मार्क्स क्वेश्चन दिस विल बी स्टार्टिंग फ्रॉम वेरी बेसिक and taking the prior knowledge of the last class also because the concept of the last class is also being required in this segment of degree. Okay, chaliye perfect. So let me introduce about myself or those who are not yet connected on my telegram channel, you can do connect with me, that is mechanical by Suraj Gopi, or if you have any doubt or difficulty you can do drop me a mail. Okay. Along with that, this is the Telegram channel that is talking about mechanical by Suraj Gopi, जहाँ से have one-on-one interaction and whatever doubts or problems that you are facing, able to help out to it. ठीक है चलिए गेट 24 का रिजल्ट आ चुका है एंड दी आर सम गुड नंबर ऑफ स्टूडेंट who secured single digit rank by using the Byjus exam prep platform. So it's very important that you also follow this step that they have followed and try to achieve success in gate 20. Okay. uh, on our app we are having the free classes. On our app we are having the free classes, that is a ground series which is occurring on our app only, exclusive classes on the app, right? And this is because gate examination is all about the basic conceptual clarity. So if your conceptual clarity is perfect, then I think you won't be having any difficulty to crack gate. तो उसी को improve करने के लिए we have came up with this ground zero series on our app. Foundation course is going on our YouTube classes और app में ground zero series classes are. ठीक है तो चलिए let's start with the first and very important segment, that is degrees of freedom. चलिए, can anyone who can tell me what is the meaning of this word degrees of freedom? What is degrees of freedom? Anyone? Degrees of freedom is basically, if I try to define, also called as mobility. It is the number of independent variables किसी भी बॉडी पे अगर इफ यू वांट टू डिफाइन द मोशन, तो व्हाट आर द डिफरेंट वेरिएबल्स यू रिक्वायर, दैट इज डिग्री. गुड वन. For some buffering issue, I think that is being rectified. Yes, everyone. Yes. चलिए perfect. ठीक है तो डिग्रीज ऑफ फ्रीडम, दैट इज DOF. व्हाट इज दिस? ये basically it help us to identify how many number of independent variables are required to define the motion. Let us take one example. Yesterday we had a discussion, not yesterday, day before yesterday we had discussion of what is the number of motions required to define this. If I say there's a body kept in a 3D space, अगर एक body है जो 3D का गया है, can you tell me how many motion this body can attain? कितने डायरेक्शन में इस बॉडी का मोशन पॉसिबल है? यस एवरीवन. इफ आई से इन द 3 डायमेंशनल एक्सिस, क्योंकि 3D स्पेस में रखा गया है, आई कैन से दिस बॉडी कैन हैव अ ट्रांसलेटरी मोशन अलोंग एक्स डायरेक्शन, दिस बॉडी कैन हैव अ ट्रांसलेटरी मोशन अलोंग वाई डायरेक्शन, दिस बॉडी कैन हैव अ ट्रांसलेटरी मोशन अलोंग जेड डायरेक्शन. 3 ट्रांसलेटरी मोशन. It can have a rotation motion along x direction, as it can have rotation about y direction, and it can have a rotation about the. तो इन टोटल कोई भी बॉडी इफ यू आर कीपिंग इन अ 3 डायमेंशनल स्पेस, द टोटल नंबर ऑफ मोशन पॉसिबल, द टोटल मोशंस पॉसिबल इज इक्वल टू 3, सॉरी 6 है। अगर कोई रिस्ट्रिक्शन, इफ देयर इज नो रिस्ट्रिक्शंस और कंस्ट्रेंट, I can say that total motion that is possible for a 3 dimensional body is 6, that is 3 translatory and 3 rotation, है ना। बट लेट सपोज हम लोगों ने क्या किया, हम लोगों ने इस बॉडी को ऐसे रख दिया, लेट सपोज आई एम कीपिंग दिस बॉडी लाइक दिस, इस पर्टिकुलर ब्लॉक को आई हैव केप्ट इनसाइड अ क्लोज चैम्बर, मैंने इसको एक क्लोज चैम्बर में रख दिया। तो मुझे बताइए नाउ in how many direction this yellow colored block will be able to move? येलो कलर्ड ब्लॉक अब कितने डायरेक्शन मूव कर पाएगा? अब देखिए ध्यान से, इट कैन ओनली हैव वन मोशन दैट इज अलोंग द वाई डायरेक्शन, दैट्स इट, इसके अलावा और कुछ नहीं होगा। इट कैन हैव ओनली वन मोशन दैट इज अलोंग द वाई डायरेक्शन, दैट इज अ ट्रांसलेटरी मोशन। तो आई कैन सी the degrees of freedom of this, let's say this is block number 1, the degree of freedom this block number 1 is equal to, ये कैसे निकाला, we can say the degree of freedom is equal to 6 minus number of constraints or number of restraints, number of restraints, मतलब इस पर्टिकुलर एग्जाम्पल में वी आर एक्चुअली हैविंग 5 restrictions. What are the restrictions? What are the restraints we are having? Here the restraints that we are having is कौन से? We are having a translatory about x, we are having translatory about z, we are having rotation about x, y and z. So these are the 5 restraints, क्योंकि ये motion possible नहीं है and we are only able to make a single motion, and that is the reason we are calling this a single degree of particular block का, block number 1 का will be having one motion possible, that is 6 minus 5, that is it, that is the degree of freedom for this example. Okay, is this clear? So only one parameter or one independent variable is required to define this motion. Done. अब इस concept को apply करते हैं to different kinematic pairs that we have studied in the last segment. But take the example of a turning pair. If I see turning pair is like, here we are having a pin joint, so it is able to have a turning motion, only a turning or rotation motion, only a rotational motion. So here we can say it is having single degree of freedom. The turning pair is having a single degree of freedom. Clear? Understood? A simple way. Clear है ये चीज? Everyone? चलिए. Let us take one more example. एक rolling pair का example लेते हैं. Let us take an example of a rolling pair. The screw pair का example. ये screw pair है. We're having this example as a screw pair. So screw pair में tell me how many number of motion is happening in a screw pair. How many number of motion is happening? लेकिन अगर नट की बात करें, नहीं कुछ, the thread, आपका थ्रेड है, यहाँ पे आपका, कैन यू टेल मी दिस नट इज हैविंग हाउ मेनी मोशंस? अब आप बोलेंगे सर यहाँ पर तो नट घूम भी रहा है और इस तरफ भी जा रहा है, इज हैविंग अ रोटेशन एज वेल एज ट्रांसलेशन। तो आप बोलेंगे क्या इज हैविंग 2 डिग्री ऑफ फ्रीडम, ऐसा है क्या? प्लीज टेल मी, इज अ स्क्रू पेयर इज हैविंग 2 डिग्री ऑफ फ्रीडम, यस और नो? यहां से देखें, थोड़ा सा रिवाइज करते हैं, हमने जस्ट अभी डेफिनेशन लिखा। डेफिनेशन क्या है? द नंबर ऑफ इंडिपेंडेंट वेरिएबल्स रिक्वायर्ड टू डिफाइन द मोशन ऑफ अ सिस्टम, राइट? सो हियर इफ आई सी, अगर मैं एक स्क्रू पेयर की बात करूं, लेट्स सपोज आपके पास नट है, आप नट को अगर खींचना चाहें, क्या खींच पाएंगे? आप जब रोटेशनल प्रोवाइड करते हैं तो ऑटोमेटिकली ट्रांसलेटरी कम्स इनटू द पिक्चर, यस? तो नंबर ऑफ इंडिपेंडेंट वेरिएबल्स रिक्वायर्ड टू डिफाइन द मोशन इज स्टिल 1। यहाँ पे सिर्फ आपको रोटेशन प्रोवाइड करना है, ट्रांसलेटरी अपने आप पिक्चर में आ रही है। क्लियर? right? So degree of freedom of a screw pair is not equal to 2, it is equal to 1 only. पूछा हुआ क्वेश्चन है बहुत सारे एग्जाम में, क्लियर? बहुत बार ये डाउट रहता है क्योंकि जैसे ये नट है, इट इज ट्राइंग टू मूव इन द डाउनवर्ड डायरेक्शन, मतलब ट्रांसलेटरी भी हो रहा है और ये अपने एक्सिस के अबाउट इट इज रोटेटिंग ऑल्सो। मान लीजिए एक्स एक्स एक्सिस जो भी मान लीजिए, तो ट्रांसलेटरी भी हो रहा है, रोटेशन भी हो रहा है, राइट? Unless and until you are providing the rotational motion, translatory won't be happening. So the number of independent variables required to define the motion is still one only. The degree of freedom of a screw pair will be 1. Okay, the degree of freedom of the screw pair will be understood. Clear हो गया ये चीज? ठीक है, अब let us take one more example of a rolling pair. Let us take an example of a rolling pair. Tell me what is the degree of freedom of a rolling pair? Quickly. A body is rolling without slip. Then tell me what is the degree of freedom of this rolling pair? 1, 2, 3, 4 or 0? Anyone? It is rolling on a, now let us take an example. यहाँ पे दो motions हो रहे हैं, we are having a rotation as well as translatory motion. But if I try to visualize, if you are trying to pull a roller from the center, rotation motion is automatically happening. या फिर if I'm giving a rotational effect, translatory motion is automatically happening. So still the number of independent variables to define the motion is equal to 1. अभी भी वो 1 ही है, आपको सिर्फ एक ही motion required है to define the motion particular pair, that is we get the rolling. ठीक है, और इन सारे पेयर्स को हम लोग बोलते हैं काइनेमेटिक पेयर्स. काइनेमेटिक पेयर्स 2D में अगर मैं बात करें, काइनेमेटिक पेयर्स आर दोस पेयर्स which is having a constrained motion or desired motion. ठीक है, राइट? अच्छा, अगर मान लीजिए हमारे पास एक बॉडी है केप्ट इन 2D स्पेस, लेट अस सी a body kept in 2D space. Can you tell me what will be the total motions possible? What is the degree of freedom? Yes, quickly. If I am able to keep this body in a 2D space, then what is the degree of freedom? Quickly. If you are keeping this body in a 2D space, तो degree of freedom क्या होगा? So this body will be able to translate along x के about translate भी कर सकता है, it can translate about y also. ठीक है, rotation हो सकता है, yes, इस plane के बाद rotate हो जाएगा ना, can rotate about z axis और इस axis के बाद इस plane के बाद rotate कर जाएगा. So there are 3 motions possible. So degree of freedom of a body kept in a 2D space, max to max we can have 3 motions. ठीक है, 3D space में we are having 6 motion possible, 2D space में we are only having. Okay, clear है? Fine. एक और example लेते हैं. Let us take an example of a spherical pair. Take an example of a spherical. अब spherical pair is a 3-dimensional kinetic pair. 3D में होता है like this. Now here we are having, it's an example of a ball and socket joint. It is able to rotate along x, along y and along, ये तीनों एक्सिस के अबाउट रोटेट कर पाता है, तो it is having 3 degree of freedom. So spherical pair is having 3 degree of freedom. The rest all the pairs are having single degree of freedom. That could be rolling, screw pair, turning pair और sliding pair. ठीक है, ये सारे के सारे का degree of freedom equal होता है 1. But if I talk about the spherical pair, it is having 3 degree of freedom because we are talking about a 3-dimensional. बाकी सब आपका 2D motion में ही, 2D में ही ये सारा का सारा motion हो रहा है. Even if I talk about sliding pair या prismatic pair, sliding और prismatic pair भी it is having single degree. ठीक है, sliding और prismatic degree of freedom is it. Understood? Clear? Everyone? कोई डाउट, कोई दुविधा तो बताइए. चलिए Now, but in our analysis, we are always talking about the combination of different links. हम कभी भी सिर्फ दो लिंक्स की बात नहीं करते. We are always talking about the combination of different links, like first link connected to the last link, and we are taking a closed chain, right? So how we can calculate the degree of freedom of a closed chain? Before that, you should be having a complete knowledge what are the different types of join. So broadly, we are having three different types of join. We are having a binary join. We are having a binary join. Binary join. Binary joint is basically when two links are having a single, when two links are connected together at a single point, then we can call this as a binary joint. ये आपका binary joint. This is a binary joint. अगर if I talk about ternary joint, what is ternary joint? Ternary joint is basically when three links are connected together at a single point. 1, 2, 3. When three links are connected together at a single point, इसको हम लोग बोलते हैं ternary joint. This is we can call it as a ternary. Right? And it is being observed that one ternary joint is equivalent to how much binary joint? Two binary joint. एक ternary joint दो binary joint के बराबर होता है. कैसे? Let us try to expand this. Let us try to connect end to end. Here if I see this is the binary joint, this we are having two binary joints equivalent to a single. Clear hai? The third one is a quaternary joint. We can have n number of examples. Max to max we can have up to quaternary joint. Quaternary joint means when four links are connected together at a single point. This kind of joint we can call it as a quaternary. And one quaternary joint is equivalent to three binary. एक quaternary joint आपके तीन binary joint के बराबर. वही सेम end to end कनेक्ट कर दीजिए. 1, 3, 4. The binary joint, ये भी binary. One quaternary joint is done. अब ये सारे इंफॉर्मेशन, ये सारे नॉलेज के बेसिस पे नाउ लेट अस ट्राई टू आइडेंटिफाई द डिग्रीज ऑफ फ्रीडम ऑफ अ लिंक. फॉर दैट वी आर यूजिंग द क्रूजबैक इक्वेशन. उसके लिए हम लोग क्रूजबैक इक्वेशन यूज करते हैं. व्हाट इज क्रूजबैक इक्वेशन? द डिग्री ऑफ फ्रीडम इज इक्वल टू 3n-1 - 2j - h. The degrees of freedom is equal to 3n-1, where f is the degrees of freedom of H, close linkage. N is the number of links. J is number of binary joint, and H is your number of higher pair. या फिर इसको हम बोल सकते हैं lower number of binary joints or lower pairs, because one binary joint is equivalent to one lower pair. Done. Okay, now let's calculate. Let us try to take some examples and let's see how we can calculate the degree of freedom. Now let's say there is a 3-bar chain. This is number 1, link number 2, link number 3. Now this is a binary joint because two links are connected together. Binary joint, AB binary joint, binary. There is no higher pair. So we know the formulation F is equal to 3n minus 1 minus 1 minus 2j minus n. हमें प्लेस करते हैं. नंबर ऑफ लिंक्स इज इक्वल टू 3. नंबर ऑफ बाइनरी जॉइंट इज इक्वल टू 3. नो हायर पेयर. कैन यू टेल मी व्हाट इज द डिग्री ऑफ फ्रीडम? What is the degree of freedom? Let's place it over here. 3 into minus 1 minus 2 हो जाएगा 3 into 2 minus 2. ठीक है. तो किसी भी चेन का अगर डिग्री ऑफ फ्रीडम 0 होता है, दिस इज हैविंग अ डिग्री ऑफ फ्रीडम इज इक्वल टू 0. So this kind of linkage we can call it as a क्या? इसी को हम लोग बोलते हैं स्ट्रक्चर और What is the structure of a frame? It's a rigid support, right? You won't be able to transmit the motion. इसका मतलब ये है, अगर मान लीजिए गलती से भी by due to any reason if you are giving input to this, आपको यहाँ से कोई भी output नहीं, there is no output being provided because the degree of freedom is equal, no power transmission happening. That is the reason we are calling this as structure. लोग trusses में करते हैं to make the trusses, to make support, right, which is able to withstand the load. अगर मान लीजिए if you are applying some force over here, this link 2 and link 3 won't be having any deflection, ये move नहीं, ठीक है, clear? And a triangle is considered as a most basic form of structure. एक basic structure बनाने के लिए we have to use a triangle, and that is the reason आपने देखा होगा whenever we are constructing bridges or any rigid support or mobile towers, it is always a combination of triangles only. Triangles के different combinations से ही we are calculating, we are taking the structure. ठीक है? Let's take one more example. Let us calculate what is the degree of freedom of this chain mechanism. बाद हम लोग special cases भी लेंगे, will be special cases. Remember one thing, we always need to assign link number 1. That means the one notation must be assigned to the fixed link. For standard nomenclature, हम हमेशा fixed link को ही we are one. This is link number 1, link 2, 3, link 4. Okay, 5 links. Binary joints कितने हैं? We are having this link 1 and 2 connected, binary joint, link 2 and 3 connected, binary joint, 3 and 4 connected, binary joint, 4 and 5 connected, binary joint, 5 and 1. So number of links, formulation is F is equal to Tn minus 1 minus 2j minus. So number of links is equal to 5. Number of binary joint is equal to 1, 2, 5. There is no higher pair. We'll be having 3 and 5 minus 1 minus 2, 5. So 3 4s are 12 minus 10. So here we are having 2 degree of freedom. इसका मतलब क्या है? What is the meaning of this? Let us suppose if you are providing input to link number 2, let us suppose, then from link number 4 and link number 5 we will be able to extract output. So here as we are not getting the desired output, आपको multiple outputs मिल रहा है, आपको variable output मिल रहा है, which is not a desirable output, and that is the reason we are calling this kind of chain as an undesirable motion. We are not getting here, we are getting degree is equal to 2, right? So if I say if degree of freedom is greater than 1, this kind of chain as a unconstrained chain. Why unconstrained? Because we are not getting a desirable motion. Desired motion now say we are calling this as clear. ठीक है, ये हो गया आपका स्ट्रक्चर, ये हो गया आपका अनकंस्ट्रेंट चेन. एक और एग्जांपल लेते हैं, जैसे एक वेरी फेमस बेसिक फॉर्म, द 4 बार मैकेनिज्म. Let's identify link number 1, link number 2, binary joint, binary joint, binary joint, and we'll be taking one example based on higher pair also. Higher pair वाला example भी लेंगे जिसमें. So here we are having number of links is equal to 4, number of binary joints is equal to 4, number of higher pair equal to 0. So degree of freedom is equal. So 3 into 3 minus 4 minus 9 minus. So here if you are providing input to one of, let's say I'm giving input to link number 2, from link number 4 I'll be extracting the output. So here we are getting the desired motion, इसीलिए हम लोग इसको क्या बोलते हैं? When degree of freedom is equal to 1, we can call it as a kinematic, इसीलिए हम इसको बोलते हैं kinematic. Okay, what is a kinematic chain? When the first link in a chain, is connected to the last link of the chain, and the degrees of freedom, or we can say the motion of that chain is a constraint motion, then that chain is called as a kinematic. अगर कोई chain का या linkage का degree of freedom 1 है, या फिर it is able to have a constraint motion, then we can call that kind of chain kinematic. पिछला वाला जो एग्जांपल था, क्योंकि यहाँ पे वी आर नॉट गेटिंग डिजायर्ड मोशन, वी आर हैविंग डिग्री ऑफ फ्रीडम ग्रेटर देन 1, दैट इज रीजन वी आर कॉलिंग दिस एज अनकंस्ट्रेंड चेन. और जब f इक्वल टू 0 है, वी आर नॉट एबल टू ट्रांसमिट पावर, राइट, दिस काइंड ऑफ चेन और क्लोज लिंकेज, वी कैन कॉल इट एज स्ट्रक्चर और फ्रेम. इसके अलावा एक और आता है, हैविंग वन मोर फिजिबिलिटी. लेट अस सपोज डिग्री ऑफ फ्रीडम, आपको एक स्ट्रक्चर का निकालना है, you have to calculate the degree of freedom and you have calculated that to be negative, तो less than 0 आया. If the degree of freedom is negative, right, मतलब less than 0, degree of freedom is, तो इस टाइप के स्ट्रक्चर्स को सुपर स्ट्रक्चर, सुपर स्ट्रक्चर और स्टैटिकली डिटरमिनेट, या तो सुपर स्ट्रक्चर बोलेंगे या स्टैटिकली इनडिटरमिनेट स्ट्रक्चर बोलेंगे. If degree of freedom is equal to 1, इसको we can is equal to 0, we can call this as structure or frame. When degree of freedom is equal to 1, we can call it as a kinematic chain. Okay. And when degree of freedom is greater than 1, we can call this as a unconstrained. Clear हो गया? Yes, everyone. Done. Structure, superstructure, kinematic chain and unconstrained chain. These are very, क्योंकि questions कभी कभार ऐसे पूछते हैं, they'll be giving you a diagram and we saying which are the following option A, B, C, D. ये आपको superstructure A होगा, B will be the frame, C will be kinematic chain and D. Basically, while calculating degree of freedom, we'll be able to have a complete. Clear? Okay, चलिए एक और example लेते हैं. Let us suppose I'm taking an example of a. अच्छा, what do we call this kind of mechanism? Who can tell me? What do we call this kind of mechanism? Even this is a cam and follower mechanism. ये rotate होता है, rotating like this, और ये जो आपका follower है, it is moving in the upward direction. This is a cam and follower mechanism. Chलिए, let us try to identify what is that degrees of freedom over here. Number of links is, this is link number 1, the fixed link, this is number 2, link number 3, link number 1. There are 3 links only. So number of links is equal to 3. Binary joint देखते हैं. देखो, between link 1 and 2 we are having a binary joint, क्योंकि यहाँ पे turning pair है. ठीक है. Between 2 and 3 here we are having a higher pair. We are having a higher pair over here. ये surface contact है. We are having the higher pair. Between 3 and 1 we are having a sliding pair, and we know the sliding pair is a lower pair. That is a lower pair. So I can say number of binary joints or lower pair is equal to 2. Number of higher pair is equal to 1. So degrees of freedom कितना आया? F is equal to n minus 1 minus 3 and t minus 1 minus 2. This 6 minus 4 minus 2. This is the kinematic chain, right? And obvious बात है, we are using this in the bikes also. Automobiles we are using this kind of cam and follower. So definitely we always be using that kind of linkage which is able to provide the desired motion. So degree of freedom 1 will always be used in the different real life application. हम ये नहीं चाहते, if you are providing input to one of the link, output is haphazard. कभी वो सर्कुलर घूम रहा है, कभी लीनियर घूम रहा है, कभी पूरा घूम रहा है, कभी आधा घूम रहा है. दैट इज एन अनडिजायर्ड मोशन. क्लियर? ओके, वी ऑलवेज वांट अ डिजायरेबल मोशन. डन? ओके, अब देखो इसमें एक चीज करते हैं. इट इज बीइंग ऑब्जर्व दैट one higher pair is equivalent to two lower pairs and one addition. को प्रूव करते हैं. Let's try to prove it. यहाँ पे we are taking this example, तो वही से ही will pin joint है. We are having a follower, having a point contact, आपका sliding bit. So basically what is happening is I am giving input to this cam and we are able to extract output in terms of follower, and we have calculated that is having single degree of freedom. मतलब rotational motion is converted into a translatory or a slider motion. कितना links है? How many links are there? This is having link 1, link 2, link 3. So we are having 3 number of links. Number of lower pairs is equal to 2. Number of higher pairs is equal to 1. But let us suppose if I say मैं इसको convert करता हूँ to a very beautiful arrangement. Now, this is also having the rotation motion is converting into a sliding motion, translator motion. ये rotation है. Now let us count the number of links over here. Let's count the number of links over here. This is link number 1, this is link number 2, this is link number 3, number 4. Fine, and again. तो यहाँ पे number of links is equal to कितना? 4. Number of lower pairs या number of binary joints कितना है? देखते हैं. This is a binary joint. This is a binary joint. This between 3 and 4 binary joint, और यहाँ पे आपका है sliding pair. आपका sliding pair, ठीक है, which is also binary joint. So number of binary joint is equal to कितना? 4. कोई higher pair है? There is no higher pair. Now if you try to visualize, if you want to remove one higher pair, what we are doing, we are adding 2 additional. देखो जी, इसका number of lower pair is equal to 2. यहाँ पे number of lower pairs increase to 4. Number of links from 3 to 4. तभी जाके हमने higher pair को हटाया. We have eliminated the higher pair. So one thing we can say that one higher pair is equivalent to 2 lower pair with 1 addition. With 1. एक higher pair 2 lower pair के बराबर होता है. उसके साथ साथ we have to add 1 addition. Then only we can say one higher pair can be understood. Clear है? चलिए, perfect. Now let's take one more example, and this is a special case. Let us suppose this is a link that is being fixed. आपका link number 1 है. This complete is link number 3. This is link number 4, and this is. चलिए, calculate the degree of freedom. Calculate. अब देखो, links, kinematic link क्या होता है? First definition that we have seen. Every link must be having some restriction, must be provide some restraints. Then only will be calling this as a link. अगर restraints provide नहीं करा, then won't be calling as a link. ठीक है, ये ध्यान रखिएगा. Now calculate the degree of freedom. Number of links is equal to 5. Number of lower pairs 1, 2, 3, 4, 5, 6. क्या कोई हायर पेयर है? कोई हायर पेयर नहीं है. सो लेट अस कैलकुलेट. F is equal to -1 -2j -h into 4 -6 into 2. So here we are getting a 0 degree of freedom. तो थोड़ा सा समझिए इसको. 0 means you are giving input, we are not able to extract output. But is that actually possible? If I try to give input over here, it will be able. If I try to rotate it like this, we are able to rotate it this one also. है ना? That simply means the calculation that we have done, it's not correct. It is not having a 0 degree of freedom. It's not a structure. We are using this in trains. We are using this in locomotives. इसको हम लोग locomotive, इस arrangement को we are using locomotives, और इसी को हम लोग बोलते हैं parallelogram linkage. Call this as parallelogram linkage and this is we are using in locomotives. तो problem आ गया भाई, क्योंकि if you are giving input to link number 2, 5 भी rotate करेगा, 4 भी rotate कर रहा है, ये क्या करें? So here we now we need to understand a special category or a special case under freedom. There are two special cases discussing one by one. That is, the first special case is the concept of redundant link. What is the concept of redundant? So what is redundant link? Sometimes what happens is in a mechanism, there are some links which is not able to provide constraint. Let's say over here, this is link 1, link 3 or 5. Sometimes in a mechanism, we may have one link which do not, one or more than one link which do not provide any extra constraint. Such link is called as redundant link, also known as a dummy link. ये आपका dummy link है, बस दिखाने के दाते हैं, तो वही है. This is only for showpiece only. It is not providing any additional constraint. So I can say among all these, I can surely say link number 5 is a dummy link. A dummy link. It is not able to provide any constraint, or we can, this is a redundant link. So while calculating the degree of freedom, we won't be taking this link into consideration. Matlab, your updated diagram will be something like this. Your updated diagram will be something like this. Now calculate 1, 2, 3, 4. N is equal to 4, K equal to 4, right? And H equal to 0. Okay. Solve it, you'll be getting degree of freedom is equal to 1. Bilkul sahi. Absolutely correct. Because we are giving input over here, we're getting a desirable output. We're giving input, we're getting desirable output. So this kind of analysis or this kind of approach, here we are now discussing about the concept of redundant link or a dummy link. इसी को हम लोग बोलते हैं redundant link. Here we can call this as a redundant link. Okay, done. अब इसी में एक और एग्जांपल लेते हैं. Let us suppose I'm taking an example like number 1, number 2. अब 5 वाला जो लिंक है, it is not a parallel, it's not a parallelogram linkage. अब यहाँ पे if I try to calculate, the link number 5 won't be considered as a dummy link. Link number 5 का dummy link नहीं, क्यों? क्योंकि now it is able to provide the restraints or restrictions. अगर यहाँ पे आप input के 5 वाला उसको रोकने की कोशिश करेगा, now it is not a dummy link. So degree of freedom is absolute. Degree of freedom is equal to 0 is absolute. Is this clear? Okay. Degree of freedom is equal to 0. Right? ये आपका होता है the first special case, dummy link or redundant. Okay, the next one is the concept of redundant degree of freedom. What is redundant degree of freedom? कभी कभार क्या होता है, there are some links even if you are not providing input, वो अपने आप मूव कर जाता है. एग्जाम्पल लेते हैं. This is input. Link 1, link number 3. So this is a binary joint, this is a binary joint. Here we are having a sliding pair. Here we are having the pair. Here also we are having the thing. So अब देखिए, if you are giving input to link number 2, let us suppose you are giving input to link number 2, तो 2 और 3 के उसमें क्या होगा, स्लाइडिंग होगा, कोई दिक्कत नहीं है. But are we able to transmit? Because if I try to calculate the degree of freedom, f is equal to n minus 1 minus 2. This sliding pair, so n is equal to 4. K is also equal to 4. 2 binary joints and 2 lower pairs. So basically K will be equal to 4. H is equal to 0. So I can say this is equal to 3 into 4 minus 1 minus 0 equal to is 1. Degree of freedom is equal to 1. Okay, 9 minus 8. तो क्या यहाँ पे सिंगल डिग्री ऑफ फ्रीडम आ रहा? आर वी एबल टू प्रोवाइड आउटपुट ओवर हियर? नो, मतलब हमारा जो डिस्कशन है दैट इज नॉट करेक्ट. अगर आप टू लिंक में इनपुट प्रोवाइड करें, दिस इज दैट लिंक नंबर, दिस लिंक नंबर 2, यहाँ पे स्लाइडिंग मोशन हो गया, लिंक नंबर 3 तो उधर ही खड़ा है, स्लाइडिंग हो गया, बट 3 is not able to transmit motion to 4, right? So here we can say the power is not being transmitted from input to output, so that simply means this kind of linkage will not be having any degree of freedom. It will be having 0. क्योंकि हिसाब से तो 1 आ रहा है, which is not. So that is the reason we are now considering one very important term, that is redundant degree of freedom. तो होता क्या है? Sometimes one or more mechanism can be moved without causing motion to the rest of the links. Such link is said to have redundant degree of freedom. फाइंड करने का तरीका क्या है? मान लीजिए लिंक नंबर 1 इज फिक्स, यू ट्राई टू होल्ड एंड 2 and 4. अगर आप लिंक नंबर 2 और लिंक नंबर 4 को होल्ड करेंगे, लिंक नंबर 3 will be able to move. Then this kind of link is having redundant degree of freedom. So in order to write this, we will be having a new formulation. F is equal to 3n minus 2j minus fr minus r, where fr is your redundant और यहाँ पे fr की वैल्यू 1 है, here fr equal to 1. अब आप कैलकुलेट करेंगे f की वैल्यू, minus 2 into 4 minus 0 minus 1, that बिल्कुल सही. अब ये बिल्कुल it is an example of frame or a you are not able to provide output, you are not able to transmit the power to the output, that means it is ठीक है, clear, understood. Special case, that is f is equal to 3 minus 1. So this is all about the degrees of freedom that we have seen. कुछ क्वेश्चंस हैं उसको सॉल्व करते हैं, have better. जैसे ये वाला क्वेश्चन देखते हैं, कैलकुलेट द डिग्रीज ऑफ फ्रीडम. अब यहाँ पे बहुत ही इंपॉर्टेंट कंसेप्ट हैं, एक 3 क्वेश्चंस हैं, उसके बाद विल बी लिंक नंबर 1, लिंक नंबर 2, लिंक नंबर 3. ये आपका लिंक नंबर 4 है स्लाइडर, ये आपका लिंक नंबर 1 है, 5 हो गया. ये कंप्लीट इट्स कॉल्ड एज अ टर्नरी लिंक. टर्नरी लिंक मतलब 3 एंड पॉइंट्स हो गई, ये सिंगल लिंक ही है बट वी आर हैविंग 3 एंड पॉइंट, दिस इज अ टर्नरी लिंक. सो कंप्लीट इज 6, ये आपका 7 हो जाएगा, 8 हो जाएगा, ये 1, ये. So there are 8 number of links in this particular chain. There are 8 number of links in the chain. Binary joint identify करते हैं, कोई हायर पेयर तो दिख नहीं रहा, binary joint identify करते हैं. 1 and 2 connection binary joint, 2 and 3 connection binary joint. यहाँ पे 3 और 4 5 और 1 4 links are connected. या फिर हम ऐसे भी बात करें, यहाँ पे एक टर्नरी जॉइंट है और यहाँ पे एक स्लाइडिंग पेयर है, तो बेसिकली वी कैन से दिस इज वन क्वाटरनरी जॉइंट, स्लाइडिंग पेयर बोल देते हैं, मतलब 1 और 4 के बीच में स्लाइडिंग, और यहाँ पे 4 3 और 5 3 जॉइंट्स आर कनेक्टेड, 3 लिंक्स आर कनेक्टेड, दैट इज अ डायनरी जॉइंट. यहाँ पे बाइनरी जॉइंट, यहाँ पे बाइनरी जॉइंट, यहाँ पे बाइनरी जॉइंट, बाइनरी. नंबर ऑफ बाइनरी जॉइंट, number of binary joints is equal to how much? 1 2 3 4 5 6 7. और एक स्लाइडिंग पेयर है, 1 स्लाइडिंग पेयर. और टर्नरी जॉइंट कितना है? हाउ मेनी टर्नरी जॉइंट? देयर इज 1 टर्नरी जॉइंट. वी नो दैट 1 टर्नरी जॉइंट इज इक्वल टू 2 बाइनरी जॉइंट, सो वी कैन से दिस इज इक्वल टू 2 बाइनरी. इन टोटल नंबर ऑफ बाइनरी जॉइंट इज इक्वल टू कितना? 7 + 1 + 2, दैट इज ठीक है. हमारे पास इन टोटल देयर आर 10 नंबर ऑफ बाइनरी जॉइंट्स, सो j इज इक्वल टू 10. कोई डाउट है तो पूछ लीजिए. तो 1 2 3 4 5 6 7 8 9 10, no higher pair. Let's calculate the degrees of freedom. F is equal to 3n minus 1 minus j minus h. So 3 into 8 minus 1 minus 2 to 10 minus 0. So this is equal to 21 minus 20, that is degrees of freedom is of a kinematic. ये आपका एक kinematic का example. Done. Let's take one more example. Calculate this one. Calculate this one quickly. How many degrees of freedom does this below mechanism have? Option A is 0, option B is 1, option C is 2. Write myself. Option C is 2 and option D. Okay. Clear? Chaliye, calculate the degrees of freedom. Calculate the degrees of freedom. This is 1, this is 4. Binary, binary. In 4 and 5, we are having a binary. 5 and okay. Number of links is equal to how much? 5. Number of lower pairs, binary 20, 1, 2, 3, 4 and 5. Number of higher pairs, oh, so F is equal to 5. Are having 2 degree of freedom. Option C, 2 is the correct. Clear hai? Okay, option C. Perfect. Last question. How many degrees of freedom does this threaded screw have? Already देखा, that is equal to 1, क्योंकि यहाँ पे rotation होगा और ये translate भी करेगा, but as degrees of freedom is nothing but the number of independent variables required to define the motion. तो यहाँ पे सिर्फ एक variable required है to define the motion, right? That is a rotation. Provide rotation, translate is automatically coming to the picture. So the degree of freedom for a screw pair is equal to, okay, clear eh? So this is all about the complete discussion of the degrees of freedom. Now we are already having the vision gate classes for 25 and 26 batch, and the best part is on 14th April we'll be having the national level gate scholarship test, so you can go attend this and you can avail up to 9. Okay, and please make sure you are attending this so as to give benefit. Gate classes chalu hai, you can attend to this interface of. Okay, that's it from my side. You can do download the PDF of this class from my Telegram channel, that is my now will be next week with a new subject, that is in next week milenge engineering class. Important topics this match, right? Slowly we'll be able to cover lot many subjects per step by step. Okay, so that's it from my side. Thank you. Bye bye. Do take care of yourself and do practice good number of questions. Thank you. Bye bye. Take care.